We've talked about the basic elements, we've talked about input and output controls, but no good Android app would really be good for anything without sensors, effectors, and storage. Sensors are a way of getting things into your app, effectors are a way of getting things out of your app to the user, and storage, of course, is a place where you can save your pictures and movies and sound recordings and data that your app generates. So the basic set of sensors that every single Android device has are a camera, a microphone, an accelerometer, and most have a gyroscope and a compass. Now with the camera, of course, you can take still and video pictures. With the microphone, you can record sound, or you can detect the presence or absence of sound. With the accelerometer, you can determine what's the orientation of the device. With the gyroscope, you can determine how it's actually moving. And with the compass, you can tell which direction it's pointed in relative to the magnetic pole in your hemisphere. Some Android devices have more advanced controls, such as temperature sensors to tell what's the ambient temperature outside the device. Some can tell you whether you're in a room in the daytime or in a room at night. Some can tell you what the barometric pressure is. In addition to accelerometer and gyroscope, some Android devices can actually tell you whether you're in portrait mode or upside down or left or right, because they keep track of the rotation. They use those lower level controls to provide you advanced sensor information to tell you, yes, my device is being held straight up and down versus laying down on a table, and it's in landscape mode with the power button on the left-hand side. And finally, in some Android devices, you're actually able to tell what's the percentage of water in the air, otherwise known as the humidity. You can do things like warn the user if the device is getting into an environment that's too humid, or tell the user that everything is really, really dry and perhaps they want to be aware of static electricity. Those are many of the ways that you can get data into your apps. But of course, don't forget the screen, which hardly seems worth listing because everything you do begins with the user tapping something on the screen. Now, once you've got some input, you want to be able to do something, change something on the screen, which is the most obvious, but also you might want to do other things to interact with your user. For example, you might want to make your device make a particular sound. Tap on the blaster and it goes, or you tap on the frog and it goes ribbit, and so forth. There's also a special kind of a motor called a haptic motor, which you can use to make your phone vibrate. You've all put your phones on vibrate mode and put it in your pocket, and when a phone call comes in, you feel it vibrate. And of course, I'm sure you've also felt the phone vibrate when it wasn't actually vibrating, that sort of phantom vibration, because we're sensitive to those kinds of particular physical interactions, but you can use the vibration in ways that makes it less likely that the user can determine a pseudo vibration. So for example, when you use the vibration motor, sometimes it's good to make it vibrate multiple times in a row, buzz, 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 because it's rare that you would actually imagine that you felt 3 buzzes in a row versus a single buzz. Most Android devices have a variety of other kinds of wireless connectivity. In addition to your cellular radio, many Android devices have Bluetooth, which allow you to interact with speakers and headsets, but they also allow you to interact with an increasing number of gadgets, smartwatches, toys, sensors that tell you whether somebody's in your house or whether or not your plants need to be watered. In addition to Bluetooth, almost every Android device has Wi-Fi support. Now, you know what Wi-Fi is. It's a way of accessing the internet using a particular high-speed radio called Wi-Fi. So in addition to having the ability to communicate over the low-speed cellular network, if you're connected to Wi-Fi, you can actually talk high-speed over the internet to either other local devices, for example, a Nest thermostat or a Wi-Fi camera in the other room, or you can actually talk all the way over the internet to something on the other side of the world. Now, from the other side of the world type of distances, there's another kind of wireless that's called near-field communication, which actually only works over a very, very tiny distance. This works in situations you might have seen, such as when you go into a store and you see a little device next to the cash register where you can take your phone and put it on the device or very close to it, a near field, and actually make a financial transaction. Your device detects the near-field communication, that's what NFC stands for, interacts with the device, authorizes someone in the cloud, for example, your Google Wallet, to pay for your transaction, gets a token which then feeds it back over the NFC to the other device, and you've ended up buying a cup of coffee. NFC also works in environments which are not intelligent devices on the other end. So you can actually have NFC stickers. So you can build something, say, in a museum that has a placard that has information, and if you want to hear more, you can even hold your phone up to the sticker and see, for example, what did the Tyrannosaurus rex, whose skeleton you're looking at, look like in real life. Now, in addition to sensors, ways of getting things into your device, and effectors, ways of getting things out of your device, every Android device has storage, and there's multiple kinds of storage. There's RAM. That's where your running apps actually live. When you tap on an app, it gets loaded into RAM, which is the highest speed of memory that you have in your Android device, and is readable and writable very quickly, and that's where your app lives. There's ROM, or harder to program flash memory, sometimes it's called ROM anyway. That's where your Android operating system lives. It's not possible for your app to accidentally overwrite it. That's why we call it read-only memory, even though it might be read mostly because you've all done system updates. But we call that ROM. Every Android device also has some internal flash memory, which is effectively like the hard drive of your Android device. This is where most of the apps live, where they've been installed to when you download them from the Play Store or when you've sideloaded them. And that's also the default place for data storage. When you take a picture, it goes into the flash memory in your internal flash. When you make a recording, because you've just had a great idea for a hit song, that recording will go into internal flash. Many, but not all Android devices also have the ability to have an SD card, sometimes called external flash, which usually is quite a bit bigger than your internal flash. For example, you might have bought an Android device that had an 8 gigabyte internal flash, but then you can put a 64 gigabyte external flash in the form of an SD card into a little slot inside your device. Most apps, but not all, can be stored on the external SD card. Inside your apps, you can decide to write data to the external SD card. So, for example, you could take and build an app that allowed you to take video and store it in the external flash. That way you could take a video that's quite a bit longer than what you might have space for in the internal flash. That's an overview of the basics of Android. Next up, let's go ahead and build our very first app, the quote-unquote hard way, using Android Studio so that you can see for yourself why the simple Android development environments can be of great value.